Let's talk about the ultimate question of origins, one that pushes right up against the very limits of physics and, honestly, philosophy. What was there before the Big Bang? Okay, let's dive into this because the answer, or lack of one, is way more mind-bending than you might think.
But to even get started, we have to ask a more fundamental question. Does the word before even make sense here? This one little question, it challenges our most basic ideas about how time and the universe actually work.
So let's try a little thought experiment. Picture the entire history of the cosmos like it's a movie. Now, hit the rewind button. You're watching galaxies hurtle back towards each other. All that empty space is shrinking, and everything is getting hotter and denser and hotter and denser until, boom. 13.8 billion years ago, it all converges on a single, unbelievably energetic point. That's what we call the Big Bang. But what happens if we try to rewind just a little bit further?
To even have a hope of understanding what might lie beyond that point, we first have to be crystal clear on what our journey backwards has taught us for sure. And here's what's so crucial to get. This isn't just guesswork. These are solid, observable facts. We can literally see the light from distant galaxies getting stretched out, that redshift you hear about, which proves space itself is expanding. We can detect this faint leftover heat from that initial hot, dense state. That's the cosmic microwave background radiation. And the amounts of basic elements like hydrogen and helium that we see out there, they perfectly match what the model predicts. So the Big Bang Theory isn't just a hunch. It's an incredibly accurate picture of our universe's baby photos. But as we keep pushing rewind on our cosmic film, we eventually slam right into a hard stop, a conceptual wall where our understanding just completely breaks down. Okay, so check out this timeline, but remember we're running it backwards. We can confidently rewind past the first 3 minutes, when the first atomic nuclei formed. We can go back to 1 second, when the universe was just this hot soup of tiny particles. But as we get ridiculously close to the beginning, I'm talking 10 to the minus 43 seconds, that's a decimal point followed by 42 zeros and then a 1, we hit it, the wall.
This moment is called Planck time. And this is where we hit the biggest problem in all of modern physics. Our two grand theories of the universe, general relativity, which describes the big stuff like gravity and spacetime, and quantum mechanics, which describes the teeny tiny stuff, they just stop working together. At this insane scale, they give us completely contradictory, nonsensical answers. It's like trying to read a book where 2 pages are written in completely different languages. Our science just can't see past this point.
So, what if the problem isn't with our physics, but with the very question we're asking? This is where things get really weird, because we have to rethink what time itself even is. You see, according to Einstein's general relativity, space and time aren't separate things. They're woven together into this single 4-dimensional fabric called spacetime.